Hello guys and welcome to this lecture about naming chemical compounds from different formulas. As you can see, I have a table of monatomic and polyatomic ions with their formulas and names. You should notice that all ions in the table are anions. Then how about cation names and formulas? All cations are named as we see them in the periodic table. For example, Na plus name would be sodium ion, and Al 3 plus name would be aluminum ion. Now we can start naming different compounds. Let's say we have a formula of KBr. What's the name of this compound? Well, it would be potassium for K plus and bromide for Br minus. So full name of this compound is potassium bromide. Please note that anions have different names than their elements, so we need to memorize the names of the anions I drew in the table. Let's do a few more examples. In this case, we have CaNO3 times 2. The name of this molecule would be calcium nitrate. Calcium for Ca2 plus ion, and nitrate for NO3 minus ion. When naming compounds, we don't need to look at the subscripts and parentheses because they don't impact how we name compounds. Now, what if we have Al2O3? Well, the answer would be aluminium oxide. Let's name one more compound. Mg3PO4 times 2. Once again, we ignore subscripts and parentheses and only use ion names. So the answer is magnesium phosphate. At this point, you should be able to name almost all compounds. However, there is one more rule for certain compounds you must apply. Here we have two compounds. One is CO2 and another is CO. What are the names of these molecules? Well, for both of them, it should be carbon oxide. But it doesn't make sense how one name could be used for two or more compounds, right? The rule is, if we are naming elements that have more than one positive oxidation state, we always must write that oxidation state in the compound's name. The charge for carbon in CO2 is 4 plus. So the name of CO2 is carbon 4 oxide. And the name of CO is carbon 2 oxide, because the carbon charge in the molecule is 2 plus. Now the question is how to determine the oxidation state of the element. The most important thing you must remember is that the molecule's net charge is 0. That means there are equal number of positive and negative particles in that molecule. Now let's get back to the CO2 case. And let me explain to you why carbon's charge in this compound is 4 plus. In my second lesson, I explained the oxidation states of A group elements and how many oxidation states each group have. So if you haven't seen that, I'll leave a link at the right corner of this video. What we know is that in every molecule, oxygen charge is always 2 minus. So all we have to do is to multiply subscript with charge, and we get 4 minus. Now, as I said before, there must be the same amount of positive and negative particles. And because we don't have a subscript near the carbon, that means that there is only one carbon in the molecule. So its charge must be 4 plus to balance out negative particles. What about CO? Well, oxygen, once again, is 2 minus. And because it doesn't have subscript, we don't need to multiply this time. So we have 2 negative particles, so carbon must be 2 plus. Let's do a few more of these. In this example, we have SO3. Now once again, oxygen is 2 minus, and we multiply it with its subscript. So the answer is 6 minus. So sulfur must be 6 plus. That means that the name of this compound is sulfur 6 oxide. Another example is Fe2SO4 times 3. Now iron is a transition metal, and all of them except silver and zinc have multiple oxidation states. So we always must name them showing their oxidation state. From the table I drew before, we can look at the CO4 charge, which is 2 minus. We multiply it by 3 and get 6 minus, which means the iron should be 6 plus. However, there is the subscript 2 near the iron, which indicates that we need to divide 6 plus by 2 and get 3 plus. And that's the charge of iron in this compound. So the name should be iron 3 sulfate. The last problem we are going to look at is Ni3PO4 times 2. Again, if we look at the table, we can find that PO4 charge is 3 minus. Now we multiply it by 2 and get 6 minus. All that's left is to divide 6 from subscript 2. The nickel charge in the compound is 2 plus, and the name of this molecule is nickel 2-phosphate. And that concludes today's lecture. I hope you enjoyed it. I hope you learned something. Please like and subscribe to this channel for more chemistry content, and see you soon. Here are the problems, and here is the answers to the problems.